Okay, we're going to continue our look at transformations by looking at horizontal translations. Now, when we're considering horizontal transformations in general, as you'll see in a moment, we're actually changing the input before we apply the function. And because of that, because that's different from changing the output after the function is applied, like we were doing with vertical transformations, we get some counterintuitive behavior. At least at first, it can seem strange to think about what horizontal transformations are doing. They don't necessarily do what you first expect. But I'll show you why that happens, and pretty soon it'll become second nature. So let's take a look at the same function again, y is equal to f of x, defined by this graph with the key points in the table of values. And now the question is saying, given y is equal to f of x, graph y is equal to f of x plus 2. Now, notice that here we're adding 2x, and that is going to happen before we plug it into the f function. What that means for us is that before we can look up what the y value is on either the table of values or on the graph, before we can look up the y value or the f of x value, we're going to actually have to add 2 to whatever our x is. Okay, let's take a look at what that means. When x is negative 6, and you'll see I've actually added an extra row here for negative 6, and you'll see why in a moment. When x is negative 6, we want to find out, well, what's f of x plus 2? So when x is 6, we put negative 6 in for that x there. And we get f of negative 6 plus 2. If we simplify that, we get f of negative 4. Okay, now, again, what we had to do was we had to change the input. We added 2 to the input before we actually put it into the function. So now we're looking for f of negative 4. And we can find that by looking at the original table, because this defines the f of x function. So f of negative 4, we look up here, well, here's x of negative 4, so f of negative 4 is that one. So when x is 6, f of x plus 2 is f of negative 6 plus 2 is equal to f of negative 4, and looking it up on the table above, that's equal to 0. So now we have the ordered pair negative 6, 0 on this new graph. Next we have x equal to negative 4. So again, because it's x plus 2, we have to take negative 4 plus 2. So f of negative 4 plus 2 is equal to f of negative 2, and looking above, f of negative 2 is negative 4. When x is negative 2, f of negative 2 plus 2 again is equal to f of 0, and that's equal to 0. When x is 0, f of x plus 2 is f of 0 plus 2 is equal to f of 2, which is from above 2. And when x is 2, f of x plus 2 is f of 2 plus 2 is equal to f of 4, which from above is equal to 0. Now, we had 4 on the table above, but look what happens here. When x is 4, f of x plus 2 is f of 4 plus 2 is f of 6. But there's no definition for f of 6 up here. And if you look at the graph, there is no f of 6 because the graph doesn't go that far. So we're just sort of stuck there, which means that the new graph is not going to exist when x is equal to 4. So let's take a look at what all of these mean. Well, on the new graph, looking at the bottom table of values, we have the point negative 6, 0. We have the point negative 4, negative 4. We have the point negative 2, 0. We have the point 0, 2. And we have the point 2, 0. So our new graph looks like that. And this is a horizontal translation to the left. And although we might have expected it was going to be to the right because of the plus 2, you can see because of this, because we were changing the input before we put it into the function, that it actually goes to the left. We'll continue with another example in the next video.